Tech in 5.
Python in practice, master real-world projects in 5 minutes. Watch our trained model in action as it recognizes handwritten digits. Welcome back to Tech in 5. Today, we're taking a step forward from training our neural network to actually using it. We'll show you how a simple model trained on the MIST dataset can recognize handwritten digits. This is where theory meets practice, and you see the real power of machine learning in action. In our previous sessions, we've built and refined a neural network capable of understanding and predicting handwritten digits. In today's demonstration, we're picking up right where we left off. No need to retrain our neural network. We start by defining the same neural network architecture, SimpleNet, which includes an input layer, a hidden layer, and an output layer. It's crucial that the architecture matches the one we use during training to ensure the weights load correctly. Once our model class is defined, we load the previously saved weights from a file. This is done using PyTorch's load-state-dict method, which applies the saved weights to our model structure. And just like that, our neural network is now ready to use, equipped with all the knowledge it previously learned, without the extra time and resources typically required for training from scratch. Next, we're going to demonstrate something really cool: uploading an image right into the Jupyter Notebook for testing our neural network with real-world data. We first set up a file upload widget, which is designed to handle file inputs through a simple graphical interface. The accept parameter ensures only image files are uploaded, preventing errors. We set multiple to false for single file uploads, keeping it simple. We then use display function to show the upload button. This renders the widget right within our notebook. An image file from the local computer now can be uploaded. Now, let's dive into what happens once we have an image ready to be analyzed. First, we have the process image function. This function takes the raw image data and transforms it into a format that our neural network can understand. The image is first converted to grayscale to reduce complexity, as color data isn't necessary for our digit recognition task. It's then resized to 28 by 28 pixels, matching the input size our model expects. This resizing uses the Lanczos filter, a method known for preserving image quality. Once resized, the image is converted into a numerical array and normalized. Normalization helps in adjusting pixel values to a scale that enhances the model's ability to learn more effectively. After processing, the image is in the perfect state to be fed into our neural network. Next, the predict digit function takes the processed image and first converts it into a tensor, the format required for computation in PyTorch. It ensures the image is batched, even if we're just processing one image, by wrapping it in a list and converting that list to a NumPy array. With the tensor ready, the model evaluates it without making any changes to the model weights. The function then identifies the most likely digit using the argmax function, which finds the index of the highest output value, or predicted digit. Let's walk through the code that takes this uploaded image and reveals what digit it represents. Our process starts by iterating over each file that has been uploaded. For the uploaded file, we first extract its name and display it. Next, we access the binary content of the file. This content is the raw data that makes up the image. We then pass it to the process image function. Once the image is processed, we pass the processed image to the predict digit function, which uses our pre-trained neural network model to predict the digit. The predicted digit is then printed out, providing immediate feedback on what our model sees in the uploaded image. Now, we'll upload an example image, a handwritten digit 4, and see how accurately our model can recognize it. I'm selecting an image file from my computer that contains the digit 4. Once I upload this file, it will be stored in the upload widget we've set up. With the image successfully uploaded, our upload variable now contains this file. Let's proceed to execute the code in our latest cell. And there we have it. The model processes the uploaded image and outputs a prediction. Our model recognized and displayed 4 as the predicted digit. And that's a wrap. Today, we've seen our neural network in action, accurately recognizing a handwritten digit from an uploaded image. Until next time, keep learning and exploring.
Stay tuned for more videos on Tech in 5.